Still got.
There's that I drew the other day. There's the
You probably gave it back.
rectifier. Okay, so here's your diode.
What lab are we on?
6.
Did we start it?
No.
Okay, yeah, we turned it in.
It's finished. You must have given it, probably gave it back.
Across the electronic
I got it.
industry, and they are an integral part of
Yeah,
the
that's right, that was
electronic
the one we
device.
handed in last
In
time.
this video,
I
we'll
didn't,
explore the inner workings and
forgot
applications
my
of the
valve.
diode in great detail.
Well,
Basically, a diode is a one-way valve for electricity.
so you just write the stupid thing down and you're still, just do it, build it until next week, yeah?
Yeah.
Or not next week.
Let's take a look at the internal.
Classes.
So they've got an ammeter. It says amps, but it would be actually ohms. You could put an ohm meter across a diode and flip it, and you'll get continuity one direction and continuity. You won't get continuity the other direction.
Right.
They have amps, but
Non-annuity.
should be an ohm sign up there.
Structure of the diode. The diode is made of a semiconductor such as silicon. Pure silicon does not have any free electrons, but the silicon used here is not pure. One part is doped with N-type impurity, and the other part is doped with P-type impurity. So
There's your
at the
NP.
N side of the diode, we will have free electrons, and at the P side, we will have vacant positions for electrons. Something very interesting happens at the P-N junction of the diode. The abundant electrons on the N side have a natural tendency to migrate to the holes that are available on the P side. So the P side boundary is slightly negatively charged, and the N side boundary is slightly positively charged. You can see the depletion region that is created. The resulting electric field will oppose any further natural migration of electrons. In short, it builds a potential barrier for electron flow.
Let's turn the lab. Perfect.
My dog will
If
get
you
me.
apply an external power source across the diode as shown, the power source will attract the electrons and holes. Electricity flow is impossible in this case. This condition is known as reverse bias of the diode. You can see that the width of the depletion region increases here. However, if you connect positive terminal of the power source to the P side of the diode, the situation is quite different. Assume that the power source has enough voltage to overcome the barrier potential. You can immediately see that the electrons will be pushed away by the negative terminal. When the electrons cross the potential barrier, they will be drained of energy and will easily occupy the holes in the P region. But due to the attraction of the positive terminal, these electrons can now jump through the holes nearby in the P region and flow through the external circuit. This is known as the forward biasing of a diode. Simply put, a diode acts like a one-way valve for the flow of electricity.
So this reminds me of a little bit of transistors.
Now,
Exactly.
let's vary the input voltage and study the diode's response to it. In reverse voltage, as explained, you can observe a negligible electricity flow. In the forward condition up to 0.7 volt, you will find a negligible electricity flow. But right after crossing this barrier potential value, there will be a steep increase in the current flow. However, you can note that voltage across the diode does not go much higher than 0.7 volts, even with high input voltage. This is due to in-forward bias condition. The diode offers very low resistance against the current flow. At the reverse biased side, applying a very high voltage will damage normal diodes and result in a high current flow. The one-way electricity flow that is characteristic of the diode leads to interesting applications like a bridge rectifier. During the positive half, the circuit will conduct as shown. The other two diodes will be in a reversed biased state. During the negative half, the reverse will be the case. So we will get the same current flow direction at the output. We can further smooth this output by introducing a capacitive filter and regulator. Our educational service is made possible by the support of our patrons. Your support at patreon.com.
Does that answer your question?
I don't know about that.
I like PFM better.
No,
You had this technology for
I'm just gonna accept it.
Thousands of years
a long time.
on Mars.
On Mars. That's how that face got on it.
Oh jeez. Yeah,
Until they got here,
conspiracy
the
theories
flights-
all around.
And avoided our detection radar,
Exactly.
except for a few
They live in
dummies,
the, they live in the water.
a few dummies over in Roswell.
Well,
They got caught. Damn it.